in number 1, can you identify for me the variable? The variable we're going to highlight in yellow. What's the variable in number 1, Mubashir? X, very good. What about the constant? Is there a constant in number 1? There is not. What about the coefficient? Isaac? 8. Remember, the coefficient is any number being multiplied by a variable and only multiplied by a variable. Okay, let's look at the next one. Hurry up, Addie. I have n plus 10. What's my variable? Shout it at me. N. Good job. What's my constant? 10. Very good, because it is not being multiplied by a variable. It is being added or subtracted to the equation or the expression. Therefore, it's a constant. And what's the coefficient? The coefficient is actually the number 1. Anytime you have a variable that does not have a stated coefficient, there's an invisible 1 there. And that's because of what property? The identity property. Great job. So because of the identity property, any number multiplied by 1 equals that number. So technically, there's an invisible coefficient of 1. Okay, the next one. What's my variable? X. What's my constant?
2.
It's really the whole minus 2 if we're being technical. And what's the coefficient?
1.
It would be the invisible 1. Very good. And the last one, what's the variable? X. What's the constant? There is no constant. And what's the coefficient? Not 12. Oh, this is a dividing sign, by the way. Sorry. That's a division sign. So believe it or not, it is not 2. But, and this is getting a little more in depth than we are necessarily going to get this year. But looking at this problem, taking the problem x divided by 2, that's the same thing as saying x times 1/2. And any number that's being multiplied by a coefficient or by a variable is considered a coefficient. So technically, the coefficient for that one is 1/2. That's getting very, very technical into different math properties. You could have said there's no constant, there's no coefficient. Either one's fine. Yes. All right, guys. Today we are going to be looking at the distributive property. And we're going to be using it in 2 ways. Because just like commutative and associative property, the distributive property can be used in reverse orders. So the distributive property is used to simplify expressions or also expanding expressions, both work, by multiplying a single term by 2 or more terms inside of parentheses. What is a word that you might already know the definition to that you hear in the word distributive? Emily?
Distribute.
Distribute. And what does distribute mean? What do you think?
To split up.
Not to split up.
Divide.
It means to give. To distribute means to give. So if we look at this expression right here, we are going to start off using variables to look at the distributive property because I want you to understand it works no matter what the numbers are. So looking at this example, I have A parentheses B plus C. To distribute means to give. I'm going to give this A. Also, what operation is happening here between the A and the parentheses? Multiplication. So I'm going to give this multiply by A to both B and C inside the parentheses. So you end up with now an equivalent expression, which is why we use the equal sign. A times B plus A times C. Those are 2 equivalent expressions. Now you could have reversed it as well. You could have had the expression A times B which, you know what, I'm going to write it this way. You can also write that without the multiplication sign as just AB. There's an invisible multiplication sign between any two variables or a variable and a coefficient, plus A times C, and then you could have reversed it. You could have reversed the distributive property by, instead of giving the common factor of A, you're going to take the common factor of A out or divide both terms by A. So I can reverse this by taking out this common factor of A, putting it outside the parentheses, and saying this equivalent expression is A parentheses B plus C. So taking that common factor out is another way of simplifying the expression. So, in my opinion, when you go from this example to A parentheses B plus C, that's simplifying to me. And when you're going the opposite way, A plus A times B plus C up, that's kind of expanding it by actually distributing it. So let's look at this with actual numbers. Look at this one below, 4 parentheses 5 plus 3. How can you apply the distributive property and create an equivalent expression, Kingman?
5 times 4 plus 5.
Very good. 4 times 5 plus 4 times 3. So you are taking the 4, the times 4, and you are giving it to both terms inside. I want you on your own really quickly to try reversing the distributive property in this third example right here. Try to find a common factor to take out. Who thinks they understood how to reverse the order of operations for that last example? What do we think it might be?
Like, you can put, parentheses between x,
Nope, you can't just add in parentheses. That would change the problem because we have two operations in this problem. We have multiplication and addition. So we can't just put in parentheses.
And it was like first you add x plus 16 and then you multiply it.
No, because this 16 right here is a constant. It's not being multiplied by 8 in this problem. What do you think, Isabel?
8 times x plus 8 plus 16.
No, because the 16 is not being multiplied by 8. What is a common factor that 8 and 16 share? 8. So can you divide both of those by 8 and put the 8 on the outside of the parentheses and simplify your equation inside? So if you divided 8x by 8, that gets rid of the 8. So you're only left with x plus what's 16 divided by 8? 2. You took out a common factor. Distributive property can work both ways by taking out that common factor and putting it outside the parentheses. Okay, so now we're going to combine what we learned about the distributive property and combining like terms to create equivalent expressions or equivalent equations. So let's start off by defining what does it mean to be equivalent. Bless you. Equivalent means that something has the same value or it is equal. So far, we've learned how to apply, oops, I'm in the highlighter, the distributive property. And we've also learned how to combine like terms. And by applying those properties and mathematical properties, they can give us an equivalent expression. And we're going to look at two examples now. Well, good. So let's keep going, guys. Let's apply these properties and let's make equivalent expressions. So in this example, 6 parentheses x plus 2, we want to apply the distributive property to make an equivalent expression. So we want to distribute or give this times 6 to both terms inside the parentheses. So what should it become? 6x plus 6 times 2. Can that be simplified even more?
Yeah.
It can be. What can that be simplified to even more? 6x plus 12. So we were not taking out a common factor in this circumstance. We were just distributing that 6. Let's look at the other example. How would you combine the like terms 3x plus 4x to make an equivalent expression? What would that become?
That'd be
7x. You just have to add the coefficients together.
Oh yeah. X have like x squared.
Only if you're multiplying x times x. This is adding. Adding is repeated multiplication, so it makes sense that you can just add the coefficients together. So now we can reverse the distributive property. When we are given two numbers that have a common factor. For example, in 3x plus 6, do the coefficient and the constant have a common factor?
Yes.
What is it?
3.
3. So I can take out that 3 and I can divide both terms by 3. So it would be x plus 2. So I just reversed the distributive property there. Any questions?